Hey everybody, this is the IM1 preview of the Chapter 3 test. I'm going to go a little fast. You can always pause it and rewind and slow down. So the first problem is x plus 3 times x minus 5. Right now, pause the video, take a minute to solve it, see if you can solve it. Go. All right, here we go. Here's how it goes. Two ways to do this. One is the box model. The box model says you just put one on the top and the other one on the side. And then you start multiplying just like you would in a multiplication table. So x times x is x squared, x times 3 is 3x, negative 5 times x is minus 5x, 3 times negative 5 is minus 15. That gives us x squared minus 5x plus 3x minus 15. And these are like terms. They are like because they both have a single x. They have the same variable, nothing else. So we combine those and we get x squared minus 2x minus 15. The other way to do this is to do what we call FOIL: first, outer, inner, last. So FOIL stands for first, outer, inner, last. So for example, the first item in each bracket is x times x. The outer item in each bracket is x and negative 5. Remember, the minus 5 belongs to, the minus belongs to the 5. So it becomes minus 5. The inner is the stuff on the inside. So the inside meaning the ones that are closest together in the brackets. That would be 3 and x in this case. So 3 times x, that's these right here. And then finally, the last, which is the last item in each bracket. So 3 times negative 5. And what we get for this one is minus 15. For the other one, for the inner, we get 3x. X times minus 5 is minus 5x. Give a little equal sign in here too, if we can fit that in. Minus 5x, this right here. And then x times x is x squared. And so together we have the same thing as we had on the left side. We have x squared. We have minus 5x. Right, just like we did here. We have plus 3x, just as we did on this one here. We have plus 3x, right, this right here. And then minus 15, just as before. And what do we get? We get the same answer as this. So 2 ways to solve it. Number 2. So next up, we are going to be told that we have a function. So we have f of x, and it's going to equal some fraction with some variables. So let's say we have x squared minus, let's do it plus 5 over 3. And I want to know what f of 11 is. Try that out right now and pause the video and try that. Go. All right, so here's what is 5 of 11. Plug in 11 into each, and I mean each, there's only one x. So f, let me actually keep the colors the same, so maybe it's less confusing that way. F of 11 equals some value of x squared plus 5 over 3. So we're going to plug in 11, right? Instead of x, we have 11. Because that's what they want to know. They want to know what's f of 11. So we're just going to replace all the x's with 11s. And that gives us 121 plus 5 over 3. And that's going to give us 126 over 3. And that's going to give us 42. Okay, here comes the next problem. The next problem says we have minus 4 times 8x plus 4y. And they want to know with an area model. Use the area model. So multiply this using the area model. Multiply. Okay, you have 1 minute. Go multiply this. See what you get. And pause the video. All right, here we go. So we have area model. What do you mean area model? And maybe you want me to explain it first, and then you can try it again. But the area model means you have a box kind of like this, and we're going to put the terms on the outside of this box so that we can multiply. So let me color code these. Maybe it'll make sense to you. So the first one we have is -4. And I'm going to make that blue. So this part right here, I'm going to put it here on the outside. And because there are two terms in the bracket, I decided to make my box 1 by 2. Right? If there were 3 terms in there, if there were 3 terms in the bracket, I would have made this box 3 by 1, but there's not. So I only need 2. And if there were a binomial, a bracket with 2 terms in the front instead of -4, I would have gone 2 by 2. I would have had a box down here, I had to fill all that. But I don't have that either. So I'm just stuck with this. And that's pretty straightforward. So again, we just multiply to fill in the box. -4 times 8x is -32x. 4y times -4 is -16y. And so that's how you do those problems. You just have to multiply in the area model. And there's a couple more like that. So I mentioned the 2 by 2. So here's the next one. In this case, we have 3x plus 2 times x minus 10. And they want us to do this area model. So this time we cannot use FOIL. So we're going to use an area model. So take a minute to try that. Go. Okay, here we are when we're back from the pause. So we have a box. And I'm going to make it 2 by 2 because there's 2 items in the first bracket and there's 2 items in the second bracket. What do you mean items? I mean terms. There's 2 terms. What's a term? Term is separated by a plus or minus or one of those brackets. So, or an equal sign, I suppose. But there are 2 terms in each one, right? There's one term. Let me just color code it. 3x is a term, so we'll put that here. And 2 is a term, plus 2 is a term, so we'll put that here. And then on the other bracket, there's 2 terms. We have x, and we have -10. That's the other term. Now, does it matter that I put x minus 10 on top but not on the left side, or that I put 3x plus 2 on the left side but not the top? Doesn't matter. I could have done it either way. It will still work out. So 3x times x times x is x squared, so this becomes 3x squared. -10 times 3x, -10 times 3 is -30, so we have -30x. X times 2 is 2x, and -10 times 2 is -20. And let's bring these out. And of course, there's these common terms here, like before. We have 3x squared minus 30x plus 2x minus 20. These together will give me minus 28x. I apologize for the handwriting. That's supposed to be an 8. And then we have 3x squared minus 28x minus 20. And that is our answer. And that's all you got to do. The next one we have has to deal with exponents. So we are going to have, let's say, 3 to the -4. And we're going to take this to the 3rd power. And what do we get? Well, there's a couple of things to notice here. And we could really do this out all the way. So maybe let's just say we forgot our rules for exponents. By the way, there's a video on rules for exponents that I have in my channel that you should probably watch. But let's say we forgot. And so really what this is this is 3 to the -4 times 3 to the -4 times 3 to the -4. And I did that 3 times because this number up top here is 3. So that's really what that is. Well, what is 3 to the -4? What we talked about in class is that a negative exponent actually flips it. It makes it inverse. But Mr. Schallenberg, how when we flip there? 3 is not a fraction. Well, it can be if you want to think of it that way. Right? Remember, 3 is just 3 over 1. And so what that means is that this actually ends up being 1/3 to the 4th power times 1/3 to the fourth power times 1/3 to the fourth power. And, so that would be 1 over 81 times 1 over 81. But, do I really want that huge number? Do you want me to put the calculator and do 81 times 81? No, I don't. All I want is that you say, hey, this is 1/3 to the fourth power times 1/3 to the fourth power times 1/3 times to the fourth power. All we got to do is add up the exponents. 4 plus 4 plus 4 is 12. And that is the answer that I want. Now, question, was there a faster way to do this? Yes, there was. Because the rule is essentially, if you have a bracket with an exponent on the outside, the rule is you can just multiply the exponents, meaning the one from the outside times the one on the inside, meaning this 3 here gets multiplied by the 4. And so what you get is you just get, you get 3. Let me use a different color. You get, and I forgot. You get 3 to the negative 12. That's what this is. This is 3 to the negative 12, also known as 1/3 to the 12th power, which, hey, that's the same thing as what we got over here. So if you want to do it faster, you can just remember that you can just multiply the exponents. And then the next thing we got to do is we got to graph. So they want to know the equation of a line that passes through a certain point and is perpendicular to a line. So let's say that our line is 1 equals 1/3 x minus 2. And I want a perpendicular line that passes through, I don't know, 0, 4. So I want the perpendicular line that passes through 0, 4. Take a minute to try that. Pause this video, see what you get, see if you're able to do it without my help. All right, here we go. So first of all, before I'm even going to draw anything, what is the slope of the perpendicular line? Well, we learned that it is the negative reciprocal of the slope. And so our slope here is 1/3. Well, what's the negative reciprocal? Well, reciprocal of 1/3 is 3 over 1. And negative, well, that's just negative. That's supposed to be a minus. So in other words, this is a slope of -3. So our line is going to be y equals -3x plus some y-intercept. Well, what y-intercept is it? Well, I already have it. It's 0, 4, isn't it? You see the 0, 4 right here? See that? So what's that y-intercept? Where is it cross? Well, 0, 4, that means it's at 4. Because if I were to draw the graph, it would be at 4, and that would be where the line goes through. And so it would be, that's a horrible drawing, but, it would be, and I apologize for the uneven line there, but yeah, maybe I'll just fix it real quick. That's a little better. Right, so that would be that line, and the original line would have been something like this, and so they would form a 90-degree angle. But you don't have to sketch it in order to figure out what it is. You just find the negative reciprocal, and hopefully they're nice, like I was here, and they just give you the y-intercept. If they're not nice, well, if they want a certain point, you just have to plug in the point and then solve for b. But hopefully it won't come to that. Next problem we have is I want a line that is parallel to a certain line. So let's say I have y equals 2/3 x minus 4. And I want a line that's parallel and that passes through some point. Let's say -3, 5. And I'm just picking this randomly. But it goes through this point, right? So first of all, what is a parallel line? So take a minute to pause it. See if you can find what's the equation of the line that goes through this point, negative 3, 5, that is parallel to y equals 2/3 x minus 4. Take a minute, pause, and go. All right, here we go. So first of all, we know that the line is going to be y equals 2/3 x plus something. We don't know what that b is going to be. This time it's not so nice. So I don't know exactly what it's going to be, but if you get at least this first part, you'll at least probably get half credit. I don't know how generous your teacher will be, but you can at least get this part. Well, we don't know the b. So what do? Well, we do know that every point that's on the line solves the equation of the line. So that means that we can plug this point into the equation and see if we can solve for b. So we have here minus 3 and 5. And so we're going to plug those in for x and y. So my y is going to become 5. And this equals 2/3 times x. And my x is minus 3. That was very fortuitous. And then I have still plus b because the b is the thing that we're trying to figure out. 3 divided by 3 is 1. So 3 divided by 3 is 1. And so that leaves us with negative, so 2 times negative 1, which is just minus 2. And so I have 5 equals negative 2 plus b. Add 2 to both sides, and I have 7 equals b. So that means that this b right here is supposed to be 7. So our answer is y equals 2/3 x plus 7. Whew, moving right along. Okay, next up is just a simple distribution problem. You can use area model or distribute the old-fashioned way if you want. So you have 5x times negative 2x plus 3y plus 5xy. And so we're supposed to simplify. So take a minute to do that. See if you can do it on your own. Pause the video. Okay, great. Here we go. So me personally, I've already showed you the area model. So I'm just going to show you the old-fashioned distribution. 5x times minus 2x. 5 times negative 2 is minus 10. X times x is x squared. And then we have 5x times 3y. So that's going to be 15 because 5 times 3 is 15. And x times y, we just say xy. And this is plus 5xy. But we're not done because these two are like because they have exactly the same variables, x, y. If it were just y, it wouldn't work. Or like one has y and the other xy, wouldn't work. If one is xy and the other one is x, doesn't work. If one is x, the other is y, of course it doesn't work. So, but the only way they can be added together is if they are like. And I talk about they're friends. They're like. And the xy's they like to get together with other xy's, and so, but they don't go with anybody else. So they can go together. So we have minus 10x squared, and 15 plus 5 is 20, so plus 20xy. And that is that. Don't worry, we are almost done. We just have a few more. I know it's a little long, but hey, you want the help. So the next one is about fraction busters. And we are going to have 7/8 minus 4x over 6, no, over 5 equals x over 10. See if you can solve for x. Go. Okay, so here we are. Thanks for pausing. Hopefully you got it this way. Fraction busters requires us to find the LCM. And the lowest common multiple is, I made this one hard. Actually, I think it's harder than the one on the test, to be honest. But if you can do this, you can do anything. So if you, let's figure this one out, and then you'll be fine for the test. So 8 times 5 is 40. 8 and 5 don't share any common prime factors. There's no factors between 8 and 5. 5 itself is prime anyway, and there's no 5 and 8. So my lowest common multiple is going to be 40. Does 10 fit into 40? Yes, it does. So 40 is good. So my LCM is 40. So what the fraction buster says is you would multiply by that LCM on each fraction. And so 40 divided by 8 is 5. 4 divided by 5 is 8. And 4 divided by 10 is 4. And you just multiply these. Okay, so 5 times 7 is 35. Minus 4 times 8 is 32. And we still have an x there. And 4 times x is 4x. And so now we don't have the fractions to distract us. And we can isolate x. And so I'm going to add 32x to both sides. Just because I like to have my x positive. I don't like having a negative x if I can avoid it. My numbers didn't quite work out, but that's okay. So divide both sides by 36, and you get 35 over 36 equals x. And there you go. Let's see. We have two more. It says write an equation and then graph the equation when the slope is 4 and the y-intercept is -6. Not a problem. So this is actually an old-fashioned question. This is, I would say, review. Now, they don't give you a nice lined... Oh, actually, they do give you nice lines. So probably looks prettier than what I'm doing here. And remember, they said they want a slope of 4 and a y-intercept of -6. Okay, so anytime I'm drawing a line, I start with the y-intercept. So it's -6. I wish my line were like a nice line. This is it's a little crooked. That's better. So -6. So I start there. So I have 1, 2, 3, 4, 5, 6. And they do give you a coordinate graph, so at least you don't have to sketch the lines like I did. So you start with the y-intercept. It's at -6, and you should probably have that labeled. The one in the book already is a book, and the test is already labeled, so that's fine. And the slope is 4. Well, what does 4 mean? Well, slope of 4 means that the rise over run is 4. And 4 is really 4 over 1. So that means that the rise is 4 and the run is 1. You can either do run first and then rise, or rise first and then run. It doesn't really matter. Typically, I do the rise first, to be honest. Although you can feel free to do the run first. That's fine. So rise of 4. 1, 2, 3, 4. And then a run of 1. 1. So I know my drawing isn't great, but there's that point. And then I just have to connect it, and hopefully you have a ruler or something. I'm going to go without it. I'm going to freestyle it. Don't do what I do. Use a ruler. I'm scared now. Not too bad. I've done worse. And there's your line. And, oh, they wanted the equation too. I'm so sorry. So that means we have y equals, the slope is 4, so 4x minus 6. And that's all there is to it. Final question. Use one or more fraction busters to solve the equation. Use one box to show your work and the other one to check your answer. Okay, so here comes the fraction. Let's see if you can use a fraction buster to solve this. It's x over 4 plus x over 5. And that is supposed to equal -12. Let's see if you can do that. Pause the video and give it a shot. Okay, great. Here we go. So fraction buster, these are going to be some big numbers. I don't really like it, and you probably don't either. But sometimes you just got to play the hand you're dealt. 20 divided by 4 is 5. 20 divided by 5 is 4. And this one I'm just going to leave alone for a second. And we get 5x plus 4x equals -12 times 20. And what that gives us is 9x equals -12 times 20. And I can divide both sides by, I can take out a common factor, divide both sides by 3. And let me use a new color. And that will give me 3x. This will be 4 equals minus 4 times 20. And so that means 3x equals negative 80. Divide both sides by 3, and we get x equals negative 80 over 3. Not super pretty, but, you know, I've seen worse. This, by the way, if you want a mixed number, this is minus 26 and 2/3. Hopefully my math is correct, but yes, that's it. Thanks for watching, everybody. Remember to like, share, and subscribe. I'm not getting any money from this, don't worry. Yeah, and then pause it, rewatch it. Remember to watch the other video I did on exponents to clear up that other one. And hopefully that helped you guys. Thank you. By the way, I'm not hiring an editor, so it's all one take.